In this video, we're going to look at patterns in problem solving. These patterns that I have listed here are the same as those that I have in your notes if you are in my Foundations of Math online class. So if you have your notes with you, you might pull them out and make some notes. Otherwise, we'll just go through this video and then you can go back and look at those. So first off, it says look for a pattern and fill in the missing terms of the sequence. For this first pattern here, and generally when you start looking for a pattern, you want to look and see if there's a constant difference between the numbers. So if I look at 8 and 13, I notice that to get from 8 to 13, I had to add 5. Okay. Continuing on from 13 to 18, same thing. I had to add 5. 18 to 23, I had to add 5. So in this case, we're adding 5 each time. So to get the next 3 terms in my sequence, if I add 5 to 23, I get 28. If I add 5 to 28, I get 33. And if I add 5 to 33, I get 38. Okay. For this next sequence here, notice that I'm decreasing instead of increasing in my numbers. So from 53 to 46, I had to subtract 7 from 53 to get to 46. From 46 to 39, same thing. I subtracted 7. From 39 to 32, subtract 7. So it looks like in each case I'm subtracting 7 from the numbers. So if I continue with that pattern, subtracting 7 from 32, I end up with 25. Then subtracting 7 from 25, I end up with 18. Subtracting 7 from 18, I get 11. So the next 3 terms in that sequence are 25, 18, and 11. Okay, now let's take a look at some of these. It says look for a pattern and fill in the missing terms of the sequence. Now if you look at these, you'll notice from 1 to 8, I had to add 7. But from 8 to 27, I would have to add 19. Since those numbers are different, then I'm going to have to look for a little bit different pattern. It's not going to be a constant addition or subtraction of a number. Hopefully you'll notice if you look at these values right here of 1, 8, 27, and 64, you should notice that these are perfect cubes. So 1 is the same thing as 1 cubed. 8 is the same thing as 2 cubed. 27 is 3 cubed. 64 is 4 cubed. So they're just taking and increasing the number by 1 and cubing it. So for my next blank, I need 5 cubed. Then for the next one, I need 6 cubed. And then for the last one, I need 7 cubed. Okay. So 5 cubed is 125. 6 cubed is 216, and 7 cubed is 343. Okay, how about the next one? 4, 9, 16, and 25. Again, there's not a constant sum or difference being taken away. You're not adding the same number each time, nor are you subtracting. But if you look here, 4, 9, 16, and 25, hopefully you'll notice that those are perfect squares. So in this case, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared. So my next one's going to be 6 squared, 7 squared, 8 squared. Okay. So I'll have 36, 49, and 64. Okay, for this last sequence, it's a little bit different. None of the numbers are being raised to a power. If I have 1, 1, 2, 3, 5, those are not perfect squares. They're not perfect cubes. I'm not adding on a constant number or subtracting off a constant number. So we have to look for something a little bit different. If you'll notice, these first 2 numbers right here, 1 and 1, if I add those together, I get 2. For my next one, if I take 1 and 2 and add those together, I get 3. 2 and 3 added together gives me 5. So then for my next term here that I'm looking for, I'm going to take the previous 2 terms and add them together. So 3 plus 5 will give me 8. Okay. Adding the previous two terms for the next one will be 5 plus 8, which gives me 13. And then 8 plus 13 gives me 21. Okay. This is called the Fibonacci sequence, and it's in the notes and also in your book as well for you to look at in more detail. Okay, the other thing that we need to look at in this video is finding an expression for the nth term. Okay, so if they're asking you to find an expression for the nth term, you may have to find the sequence first, but then they want to know in general what's the rule for the sequence. Okay, so let's go back one and look at this first sequence that we looked at just a minute ago. In this one, we were adding 5 each time. So from 8 to 13, we added 5. 13 to 18, we added 5. So in this case, if you have a number that's constantly being added or subtracted, the first thing you're going to start with is you're going to take that number and you're going to multiply it by n. Okay. Now, one thing to make you aware of, all n is talking about is the position in the sequence. So 8 is when n equals 1. 13 is when n equals 2. 18 is when n equals 3. It's the third spot in my sequence. Okay. Now, what we need to do is find a general expression for this sequence. So if I start with 5n, I want to go back and look at my first term. When n equals 1, who was in the very first spot in my sequence? I need 8. Okay. So I'm going to plug n equals 1 in for the n that I have. And 5 times 1 is 5. But I need 8. So what do I have to do to 5 to get 8? I have to add 3. Okay. So I'm going to take this value right here and put it back up here with this 5n and say plus 3. Okay. This is an expression. Remember, expressions don't have equal signs. And let's check it for the next few terms in my sequence. When n equals 2, if I plug in 2 for n, that would be 5 times 2 plus 3, which would give me 13. Was 13 my second number in my sequence? Well, if I look back over here, yes, it was. So it checks for that one. Let's try one more. Let's try n equals 3 and just be sure that it holds. So if I plug in 3 for n, and then I add 3, 5 times 3 is 15, plus 3 is 18. Was 18 the third number in my sequence? Yes, it was. Okay. So whatever value you have here that you're constantly adding or subtracting, that's the number that you're going to multiply by n. And then you figure out what you have to add or subtract to get that first number. Okay. So for this one, 5n plus 3. Let's try another one. On this one, this was the second sequence we did. We were subtracting 7 each time. Okay, so same as before, when I'm looking for the expression for the nth term, since it's a constant difference in this case, I'm going to put negative 7 times n, okay, automatically. And then I want to figure out what I need to add or subtract so that the expression holds for this sequence. So when n equals 1, I would have negative 7 times 1, which is negative 7. But remember that n refers to the term number in your sequence. So when n equals 1, I need 53. Okay. Well, if I plug in 1, I get negative 7. So what do I have to do to negative 7 to get 53? I have to add 60 to it to get my 53. Okay. So if I come back up here and put plus 60, let's check this expression out and see if it holds. So when n equals 2, I have negative 7 times 2 plus 60 based on my expression. Okay, negative 7 times 2 is negative 14 plus 60 gives me 46. Is 46 the second term in my sequence? Yes, it is. Okay. If you plug in n equals 3 to this expression, then you'll get 39, and you'll see that it works. Okay, now, what if we don't have a constant sum or difference? So if you'll remember in this case, we were actually, I think I skipped. Here we go. In this case, the next one that we did, we were looking at cubes. Okay, so this was 1 cubed, this was 2 cubed, this was 3 cubed, and so on. But they want us to write an expression for the nth term. Well, remember, n is just the location in your sequence. So here, n is 1, n is 2, n is 3, n is 4, etc. So all I'm doing is taking the term number and I'm cubing it. So you'll notice that this one matches with this one. This 2 matches with this 2. So my expression in this case is just n cubed. Now, let's compare that to this one below it. Here, I don't start with 1, I start with 27. So 27 is 3 cubed. 64 is 4 cubed. Then I have 5 cubed. Okay, so instead of starting at 1, I'm starting with 3 cubed. But when I'm talking about my sequence, remember n is where you are. So this is still when n is 1. 64 is when n is 2. 125 is the third spot, so n would be 3. So up above, my n was 1 and I was cubing 1. My n was 2 and I was cubing 2. Here, my n is 1, but I need to cube 3. So what do I need to do to 1 to get 3? I need to take that n and I need to add 2 to it, and then I need to cube that value. So when n is 1, I add 2 to get 3, I cube it and I get my 27. When n is 2, if I add 2, I get 4 and cube it and I get my 64. So my expression in this case is n plus 2 cubed. Oh, just a second, I lost my spot. My board's not working very good. Okay, let's try this again. Okay, here's the last one that we need to look at. Find an expression for the nth term. Now, this is the other one we looked at. In this case, we're not cubing, we're squaring. So here we have 2 squared. Then we have 3 squared. Then we have 4 squared. Okay, again, remember that n is corresponding to the position. So this is when n is 1, 2, 3, 4, and so on. So when n is 1, I need 4. I know that I can get 4 by squaring 2, okay? But I need an expression with n in it. So when n is 1, if I need 2, I need to add 1 to it to get my 2, take that value and square it. Then see if it holds for the 9. When n is 2, if I plug in 2 for n, and add 1 to it and square it, that gives me my 3 squared. So for my second position, that would give me my 9. And you can continue checking in that manner.